color this currently by, I'm not sure what we're looking at there actually. So, up in plasma, so this is the gene set associated with 161. There we go.
That's 165?
166. Up in plasma B cells, 166.
Oh.
And we can also do up in plasma B cells, 165.
Oh, I see. So
Those are kind of diametrically opposed. But I'm not sure what's special about this island that it's getting turned on and off based on those two.
So the blue is the high ones in that case?
No.
Or no, I'm sorry, the cluster. I don't know what. Oh, yeah, the blue are low.
Right. It's based on a color map like this.
Okay.
So the lowest ones have a value of 7. The highest have 700.
But these little green ones then switch colors. Is that right? Oh yeah, that's good.
They switch between. So let me create a little summary here. If I had, it was a QC population. If I had this, we could kind of save our work and compare between the
My
two.
arm's getting tired.
All right. Well, my hand is perfect.
Right. No, you're perfect. No, it's good.
That's good. Lower's better.
So
No,
that's
stand
up
up,
in
please. It's
165.
good.
Here's up in 166 again.
I see. So this is so they're different. Is that right? The green is opposite. And that would be nice if that, especially if we knew what it meant.
So what this means is that the sum of expression for those gene sets that we looked at is up all over here for 166, and it's up only here for 165. So that because of the way we define them, they're kind of always going to be opposed to one another.
Right. So is there a way to, I guess but which ones, what are those little subpopulations? I know you draw gates around them, but for example, if you want to know one by one, I mean, I guess I kind of suspect those are, I don't know, different.
Different. We have these populations of plasma B cells from the two different patients. And we can look at where those plasma B cells are in relation to these different islands.
Right. Can you do an example of one of those? Just pick an island.
Oh, well, I was just thinking to look at them among all the islands.
Oh, okay. That's even better.
And then the dots are too small for me to tell where they are, so I'll use large dots here. And then you can see kind of how what we identified as plasma B cells are distributed throughout these different islands in UMAP space. And so, for example, this island has something special. It's distinguished only by 165. Or no, I can't even read that. It's one.
That's right.
Yeah, 165.
Is there a way to figure out what's in that island? To save it?
Yeah.
What genes?
Just at that island.
What genes are driving that island? Oh, there you go. Oh, yeah, right. You did this.
And then depending on what we want to do with that. There it is.
That's interesting.
Like look at the genes that are in there.
Yeah, so usually that would mean doing some kind of differential expression analysis, and we need something to compare with, which could be everything else.
Right. That would be okay.
Always kind of my default is to look at that versus everything else. So that's going to take us back to a volcano plot. So I want to find everything that's not in the pop of interest. There it is. So pop of interest minus, and then the population of interest itself. There it is. You know, everything on the right here is our up in population of interest.
Really, there's just, well, I was saying just a few genes. Which is-
98 genes in there.
Oh, really? All right. Are these them?
Quite a lot.
Yeah.
That's a lot.
Yeah. Actually, granzyme doesn't. We don't want that in there. But I wonder if these are.
But they all have the hemoglobin gene.
Yeah. There's ID2. That's your favorite
Should
gene.
be all B cell.
The RIG.
I thought they are gated. Oh no, not really.
There's CD2. Can you pick, Ian? That was good. They look like they might be contaminants or something. I don't know. Because they got CD2, which can be in a B cell, but not usually, and other genes that.
There's all these cytotoxic molecules.
Right.
I don't think those are typical of B cells.
Yeah.
I mean, it could be.
No, I know. Benga's proposing, okay, this is it. We found out the green.
It could also be, I mean, this population contains some of those plasma B cells from population 165.
Yeah.
Maybe there's some big distinction between the B cells in this island and the rest of the data.
That's true.
There's no reason to think that those are necessarily the same, you know, the
Right.
same phenotypes, for example.
Right.
Can you look at another one that's sort of high by some criteria? You know, go back to get a population that's not such an outlier. I mean, maybe slightly outlying, but not too much. Where we have to make a hypothesis that cytotoxic B cells are autoreactive. Like Benga's about to do. You know, we'll get around to that, Benga, don't worry. We'll keep it in mind. A more regional population.
And look at that. So CD3E is pretty high in that population.
Oh, I
That's
see.
probably contaminating
Yeah.
T cells, right?
Right.
Right, the darn CD8 snuck in.
Yeah, I'm not sure how we want to pick a particular island, I guess.
Yeah. Huh. That's interesting though, because I thought, we defined the CD19, positive versus negative.
We definitely did. Let's see, so...
Yeah, so, which is kind of like my question is like, even how do you even set the positive versus negative in that gate?
Well, you guys had mentioned early on using some kind of like a gene set to define a population, as opposed to one particular marker.
Yeah.
It's a great idea.
Yeah.
But where do you get? I mean, we have some gene sets like that. We could try them out really quickly here. So if I go to my desktop, I think I have a folder here that's just gene sets. Immune gene sets in helper D. I was hoping I had something a little bit more robust in terms of like, I know we have developed in the past, up in B cells, down in B cells, and then you can look at the two and do a negative exclusion on one and a positive inclusion on the other, and that might lead you to a more robust definition of your B cells.
That's right.
But in this UMAP that you just put here, those are high in one. What are they? One high in 165 and not compared to 166, or what is that?
Well, the way that we decided that population might be interesting was back here in the layout. We did an overlay of these two populations, and we said, okay, there are some number.
Oh,
mean,
I
it's
see.
It's probably less than 10 cells from this plasma B cell population from patient 165 are in that island.
Oh, I see. So you're saying the other islands have plasma cells from both?
And also, notably, this island, unlike many of these others, it looks like,
Right.
contain nothing from patient 166.
Right.
But it doesn't really tell us much about those individual cells in terms of their phenotype. We might still think these are plasma B cells. a little bit hard to say at that level, or that, we're zoomed way out.
Yeah.
So these are just populations that are variable according to the UMAP algorithm. And certainly this one to me looks like it could be at least mostly contamination based just on that color mapping with,
Now, is UMAP maybe the best way to, because we know that plasma cells 165 are different from 166, but UMAP says, oh no, they're not really too different. But is there another algorithm you can run to look at,
dimensionality reduction?
yeah, something like that. Yeah, another dimensionality reduction. That, because 165, that will really show, I don't know, show that there, whatever is different about them, some better way.
Yeah, so there's quite a few we could use, but TC would probably be the next one I would go for.
Okay, sounds good. Is this just those cells? Tizian, just those?
I think it's the one you selected, right?
I don't know. Are these just the ones we selected?
These are the, whatever I defined as QC pop. I think I actually have a layout that shows how I did QC here. Where is it?
Oh boy.
Might just be my first layout. Yeah. As soon as this refreshes. The QC pop is defined here by library size versus genes expressed.
But I think it was, you somehow got to plasma cell, or plasma blasts, based on,
Yeah, and we could do TC straight onto the B cells, or any dimensionality reduction can be run at any level of the hierarchy.
Yeah. In a quick question. So let's say, initially you generate the principal components of using all the QC population, which might include B cells and any other contaminating cells while they were isolated, right?
wait, I don't know.
With the generated piece, the principal components that you had with all the cells, is it reasonable to use those same principal components, let's say then you define, you want to look at if there are 20 subsets of naive B cells, would that pieces still be able to give you, relevant information on trying to further separate out the naive B cells, into whatever number of clusters that you want, or you think there might be? Or should
It's definitely going to be our recommendation that you go back through the quality control.
Okay, all right.
So, for example, here's CD19 positive. What we were thinking are probably the B cells, or not. You guys are totally on top of it in terms of, you have dropout events that remove some potential B cells, and on top of that, you have the opposite occurring as well, right? You have cells that are not B cells, but which have transcripts associated with B cells, like CD19 CD19 expressing, but not. What do I say?
They're not characteristic.
Not expressing. Transcribing but not translating.
Oh, right. That's possible.
So this is going to be the outlier filter genes specific to, if I can make a date. think my machine has about had it. It's starting to hum at me. Yeah, so anyway, I would be repeating all of the QC processes that we did, or that I did before we even started this meeting on the B cells specifically.
Yeah, and then generate like a principal components just for those B cells.
Exactly.
Okay.
Well, I think you're getting very, very close. You know, maybe we can look at what you, if you can send us all the files, and we can sort of try to reproduce what you did and explore further.
Okay.
I really like the naive versus plasma blast plots, because that shows where they started and where they ended up, and they appear to be different in the two subjects. So
Yeah, and I took down your feedback on, obviously being able to export that table.
Right.
So you can look at the numbers and create your own ratios and see, even just sort within a table.
right.
Or genes of interest in that variable gene repertoire.
Well, you have that table had an export button at the bottom, but it just didn't work.
We should have been able to export that. I think that's just one of the areas we have not tested thoroughly enough. But
Right, that would be really important to get that to work. I mean, not just for me. I think everybody would have the same question.
right, I totally agree. Totally agree. So now we're on rerun PCA. We call this pause. Select only these. I have these first genes for B cells, just like you were suggesting. I want to make sure they're on ones for sure.
Oh, that's good. Yeah, go ahead. Let me start a new file.